All right, this here is a constant. This is a constant. This is our friend E, which is about 2.7. This is the rate of growth, and this is the time. This kind of curve has a fancy name. It's called the sigmoidal curve, but we'll just go with logistic growth model. And we're going to give you a specific one. I'll do it on the back so I can work some fancy stuff. Y equals, our A is 5,000, and our B is 4999, very close to 5,000. E to the minus 0.8 t, where t is in days. It could be given in other units of time, like months or weeks or years. Let's say there are 5,000 people at a school, and those people are exposed to, say, a flu bug. And when 40% of those are sick, they're going to close the school down for a few days. So, how long will it take in days for the flu bug that has started with one student to reach 40%? So we'll identify this as the number infected. These are kind of problems I'm preparing you to do. So the number infected are right there. So can you see when time equals 0 at the beginning of this problem, what happens to this value? At time equals 0, or when the problem begins, this would be 0, negative 0.8 times 0 is 0, e to the 0 is 1, and we have 1 plus 4999 times 1 becomes 5,000. 5,000 over 5,000 is 1. So at time 0, as I said, one person is infected, and the problem begins. When will 40% be sick? All right, so what we're going to do is find the answer in days. So first of all, there's 5,000 in the school, so 40% would be 40 times 5,000. So we need a number before we can go on. And 40% of 5,000 is 2,000. So that's what we want to find when there are 2,000 infected. So I'm going to put 2,000 for my Y, and everything else the same. And my command to you is to find T. Now T is down here in the denominator right there. So I want you to follow your mathematical nose and get the T up. Since it's in the denominator, let's multiply both sides by this expression. It will disappear from here and reappear from here on this side. So it's going to, when I multiply both sides by this, it'll be gone from here and it'll reappear over here. So that would be the 1 plus 4999 e to the minus 8 minus 0.8 t. All right, now I want to move the 2,000 over here, so I'm going to divide both sides by 2,000. This is gone, so we're going to have 5,000 divided by now 2,000. All right, so left over on the left is still the 1 plus 4999 e to the minus 0.8 t equals 5,000 divided by 2,000, which I'll just reduce to 5/2. That's good enough. All right, again, I'm solving for t. So I want to get e to the minus 0.8 t by itself. So I'm going to move the 1 over by subtraction. And divide by 4999. All right, calculator challenged here. So I don't know what that number is on the right, but I'll let you do it. On the left, 5/2 minus 1 divided by 4999, whatever that is, you get it for me. Now I want to get the t down, and you've been trained to solve exponential equations. So in order to get this down, we're going to use log rules and take the ln of both sides. And when we do that, this can run down in front, and we get negative 0.8t. Now it's down where I can use it, and it leaves ln e of e. So what exponent do I give e to get e? This is just a 1, so I won't write it. And over on this side, I have ln of that number you have found for me. And now, to finish, to get t, the final t, I divide both sides by negative 0.8. So, what is ln of 5/2 minus 1 divided by 4999, whatever that number is, divided by negative 0.8? I did do that part, and I got all of this together to be 10.1 days. Alright, so that tells us at the rate stated, the school will shut down. It will reach 40% having contracted the flu. And if this is a good model of the sickness, then we will know in 40 days, I'm sorry, 10 days, we will be 40% infected and we'll have to shut down for a few recovery days. Alright. Other equations in our work tomorrow will pop up with logs or exponents in them. So I'm sure you've heard of the Richter Scale. Well, earthquakes are evaluated with the Richter Scale, and it is logarithmic. So, and it is logarithmic to the quantity I, which is intensity of the wave energy that the earthquake presents. So in Sumatra in 2004, the Richter scale measured 9.0. So I might ask you to find the intensity of the waves that were created during a 9.0 earthquake. So what you would do would be solve this. Log means base 10. To solve a logarithmic equation, we exponentiate both sides. So this is going to be an exponent, and this is going to be an exponent. It's going to be an exponent to the number 10, because the log is to the base 10. And we learned that when you raise 10 to the number you raise 10 to get I, you do get I. So we have I equals this number here, 10, so that's to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so this was a very powerful, what is that, a billion, 1 billion. The intensity in intensities per square unit of area, so it's very large, very intense earthquake. Alright, there's so many different equations that involve exponentials and logs, but that'll give you a taste of them and give you confidence to do your work tomorrow. Alright, over and out for now. Catch back up on your rest, and I'll see you Tuesday morning. Good night.